API Academy video series. In this video, we provide an overview of the most common API styles. For each of the API styles, the following are discussed as applicable: a brief history and why it became popular, a glimpse into the protocol stack, the most common approaches to how each style is implemented, and the advantages and limitations of each. Firstly, styles or standards. People often get confused between standards, a set of rules, and styles, a particular mode of expression. Let's take a moment to look at the difference between the two. Standards are usually formal documents that establish uniform engineering or technical criteria, methods, processes, and practices. These organizations define Internet standards. Styles, on the other hand, are rather abstract plans such as architectural blueprints, engineering drawings, or business processes. Similar to architecture, when designing buildings, various architectural styles exist for APIs too. Using a predefined solution structure helps you speed up the process of designing your API solution. In this training module, you will learn about the following API styles: tunnel style, URI style, hypermedia style, and event-driven style. Let's take a look at tunnel style. Tunnel style is sometimes also referred to as web service style. SOAP stands for Simple Object Access Protocol and is the most well-known implementation of the tunnel style. Tunneling APIs build on the common pattern of calling functions within a programming language, but extend that pattern to remote services. A tunneling API like SOAP normally exposes an RPC-like interface and provides an interface descriptor for binding, uses an XML-centric message format, and uses HTTP as transport protocol for a higher application-level protocol. SOAP was designed in 2001 with the goal to provide a universal way of connecting applications. If your application wants to talk to another application, SOAP is a way of encoding content in a way that the messages can be universally understood. SOAP has been closely tied to HTTP since the earlier versions, and to this day it has very limited usage of other protocols than HTTP. The protocol stack shows standards for many possible use cases of SOAP. SOAP defines an RPC-like interface for application integration and utilizes a standard called WSDL or WSDL to describe the interface. Client applications can generate proxy code based on the WSDL document and make calls as if the remote component is local. The most common implementation model for SOAP is to focus on the functions and methods. The service provider creates a WSDL document and publishes it, which allows potential consumers to consume the WSDL and generate proxy classes that will use those web services. Here are some advantages and limitations of SOAP. As an advantage, SOAP was a logical follow-up on standards such as the COM or CORBA. There is a good toolset for SOAP services available for publishers and consumers. And because you can see all the metadata associated with services, there is a whole toolset around governing SOAP services for enterprises. As for the limitations, there are stack dependencies in that SOAP implementation would often tie you into a particular toolchain. SOAP is very XML-centric, built in XML, and therefore not very flexible. By using HTTP as a protocol but building new methods for packaging and executing calls, SOAP is not able to take advantage of native features like HTTP caching, URIs, operations, status codes, and so on. The explosion of supporting standards for governing reliability, transactionality, security, orchestration, and other characteristics was what eventually became the downfall of SOAP, as people complained it was too fragmented and too complex to use. However, it's still being used, and some companies are still offering SOAP services or dealing with legacy SOAP. If the customers are happy with the status quo, it's not worth discontinuing its use just for the sake of design. Next is URI style or CRUD. CRUD stands for Create, Read, Update, and Delete and refers to operations performed on a resource identified by a web URI. URI-based APIs provide an intuitive, simple way for application developers to invoke requests. Well-designed APIs of this style employ hackable URI designs, which also act as a form of self-documentation. The reliance on the HTTP protocol can also act as an advantage for client application developers who are familiar with the protocol. URI's roots go back to the history of the web. It uses the standards that formed the web: HTTP, URIs for addressing resources, and XML and JSON for formatting data. There are different RFCs that define the protocol for HTTP. There are different media types that you can use when communicating over HTTP. For example, HTML is typically used for web browsers. XML was created as a way of exchanging data without being tied to the convention of HTML, and JSON came out of the JavaScript object world as a way of encoding data in a more efficient way than XML that is also more human-readable. As opposed to SOAP, where you focus on function, the common implementation model for URI style focuses on objects referred to as entities or resources. In essence, it's like describing nouns instead of verbs. First, you decide what your objects are. Next, you can design URIs that are a representation of those objects. You can then design query rules. On top of those resources, you would use HTTP method as verbs, such as put, post, get, delete, as a way of interacting with those resources. It's all about using native HTTP mechanisms to build an API. Some advantages to URI style. URI style is very common and very well known, and there's plenty of tooling out there. Also, if you find an API that uses this approach, it's relatively easy to start using it and build apps with it. However, this style is not without its limitations. For example, there is no standard approach to URI modeling, so each implementer has to determine their own guidelines. Another is that it's difficult to map a complex set of application interactions to the simplified set of 4 HTTP operations acting upon a resource. This can lead to URI designs that become increasingly complex, resulting in a steeper learning curve for developers. Finally, this object-based interaction style may require applications to make multiple requests in case where many collections of data resources are required to achieve a task. In other words, a URI-style API may encourage chattiness, which can be detrimental to perceived application responsiveness for end users. Up next, we have the hypermedia style. The style is similar to URI style, but utilizes hypermedia, which includes rich content types, hyperlinks, and other native HTTP tooling, to create interactions focused on tasks rather than on objects. Essentially, these are browser-based interactions for machines. In much the same way that you use links to navigate the web and forms to provide input, a hypermedia API provides links to navigate a workflow and template input to request information. The interactions between the client and the API provider are more self-describing and intuitive. Some characteristics of a hypermedia API: it exposes a task-based interface, often incorporating a workflow or state machine. It uses media to describe link semantics, template-based input, and message structures. And it provides its own URIs. The history of REST architecture goes as far back as the early 2000s, when Roy Fielding wrote his original dissertation. Over the next decade, the REST style evolved from being applied to web service architecture to its current offering of RESTful web APIs that developers can use for their client applications. The REST protocol stack built on the core of HTTP and related standards. Native HTTP operations, headers, and status codes are extended using new media types that better reflect a conversational set of transactions between an intelligent client and a self-describing service. As opposed to CRUD-based services, hypermedia API implementation focuses on the tasks and use cases to be accomplished by the consumer. Selection of an appropriate media type, something like HAL or collection plus JSON, is an important decision, as it will determine service interaction styles and what client tools might provide support. Tasks to be accomplished are mapped to forms and links in the API, and the server maps these interfaces to internal storage. The client then uses the links and forms in responses to interact with the application. A key benefit of REST is that the media types can be selected to suit the needs of API consumers. There is also a growing body of guidance to help design effective self-describing APIs that rarely requires versioning. When designed correctly, a hypermedia API can evolve over many years and continue to support applications that have been developed during its infancy. On the other hand, there is a lack of mature tooling and support for this type of API. To date, there is no standard hypermedia representation. Each protocol has a different view on which information should be included in hyperlinks. Consequently, some developers see hypermedia APIs as excessively complex. Another common concern is that the client must evaluate the hyperlinks instead of using hard-coded URLs to access the API. Also, evaluating hyperlinks requires the client to understand the relations between the hyperlinks and how to best act on those relations. Last but not least, we have event-driven style. API interactions based on event-driven architectures have gained in popularity recently. A popular example of the event-driven style is the WebSocket protocol standard that has been incorporated into the HTML5 specification. WebSockets provide a useful way of transmitting data with low overhead in both directions between client and a server. A web API designed using the event-driven style will typically exhibit both of the following properties. The client and or the server listen for new events, and events are transmitted via synchronous messages as they occur. While some event-based APIs utilize the HTTP protocol, there is a growing body of network-based protocols like WebSockets that favor low-overhead asynchronous communication. This style of API can be very effective for applications that need to frequently update UI widgets or for bidirectional message-intensive applications such as multiplayer video games. However, WebSockets APIs require additional infrastructure considerations beyond the traditional HTTP-based API components and are not well suited to request-reply interactions. Finally, let's take a quick look at some emerging API protocols. GraphQL is an open-source query language for APIs, originally developed at Facebook. It was created to provide more granular control over what data is sent and received between the server and the client. GraphQL allows client users to tell the API exactly how to present the retrieved data without needing to create a large collection of unnecessary requests or responses. gRPC originated at Google and takes advantage of the HTTP2 protocol. It's a high-performance remote procedure call framework that uses protocol buffers as the data encapsulation protocol. It is language agnostic and emphasizes a contract-first approach to API development, which requires client and server to agree on the payload format but allows for performance at scale. You've reached the end of the API styles video. You should now be able to distinguish between API styles and API standards, name the most common API styles, and understand some advantages and limitations of each. Thank you for watching. We will see you in other installments of the API Academy Learning Series.